All right, in this video, I want to go over some of the basic differences between different Linux file system layouts and how operating systems upgrade and how you can use them and which one maybe you should choose for whatever it is you're trying to do. So to start out, we're going to look at a traditional file system on a hard drive. And when Linux is running on your computer or on a server, whatever it is, it has these file systems all under this root path. And root is basically the main mount point for all of your files. And you can put these things in different file systems, like a different disk or remote file system, something like that. But it's all represented under this slash. Under, if you're on Windows, this is your C colon basically. But in Linux, it doesn't have to be one drive. It can be multiple. And like I said, when you install Linux, it just starts writing these files to disk. It extracts them from the installer, puts them on your file system, and then usually runs some sort of like update command during the install process, which is going to go fetch the latest version of something and write it to those locations just to make sure that you're not running an older system, because things change all the time with Linux distros. And this is how a majority of Linux systems work. They just take those files, they write them to disk. Great. We can update those as we need, and whenever we're doing something like an apt update or like DNF, those just they fetch those files and they write them to disk. And then when you're changing things, if you need to configure something, you go into that file system or that folder and you change the files. And as you're doing these updates, it tries to make sure, have you modified this file? Should we keep your changes versus someone else's from like upstream? How did that happen? How do we make sure that we can upgrade safely from version to version? In this style of Linux distro, we usually have a hard break for a new version. So this might be something like an Ubuntu 2404, right? Like the new version's out, and this is the old 2310. And so we're not going to upgrade beyond that point. We cut off all of our packages at some point and we cut over to a new version. And so what some distros have started doing, something like a SUSE Tumbleweed or Arch, what they do is they kind of break down this barrier, and they don't have releases. They just have what's called a rolling release. And so you don't ever stop your packages. You just continually roll to the next version, and you upgrade, new. If major new packages come out that have breaking changes, you pull those in and you upgrade them. And that is fine in some situations. Similarly, like people don't like re-updating their OS every year. So they can just continually do small incremental updates over and over again. But that's kind of hard when there might be a breaking change, because those packages aren't always backwards compatible. Something that's, in this new etcd, if we're pulling in a new glibc or something that's kind of critical to the system, it might have something that breaks, and we can't guarantee that things we have running from a long time ago will always be up to date and always support the new things. So something that Chrome OS and Chromebooks actually started doing a long, long time ago is they would break the system down and have two partitions. And they would write all of the files into two locations. And they'd say, okay, this is partition number 1, and this is partition number 2. And partition number 2, let's say we booted to 1 over here. This is the one we're on. Partition 2 would pull down updates and write them all to a new partition and not change the old one. All of the old critical files were in place. And so we could roll from an old version to a new version by rebooting the system and booting over to number 2. Of course, this added some complexities, like how do I get my configuration I wrote in partition 1 over to partition number 2? And they would solve that by creating more partitions that would allow you to write in a certain area of the file system. So this area is read-write, and I can write my files here. Some things get symlinked here, like etc. So when I reboot to the new system, it's the same actual partition that goes from one version to the other. And I don't have to worry about overwriting those changes, because those are going to always be the same. That's where I can change my configuration. But these other things that I don't usually change, like user and bin, I can just inherit those from upstream, and those aren't writable to me. These areas are all read-only. They're all read-only mounts that I can't change. And so Chrome OS started this, and they started doing this a long time ago, and it was a really safe way to roll out these massive updates to a lot of people that had computers, and that's why you have to reboot a Chromebook whenever it has updates. You can't just sit there and let it do updates in the background. Every time you have to reboot because it switches these partitions. Now, 10 plus years later, lots of things do this. Your Android phone does this. The original Core OS did this. They actually took these ideas from how Chrome OS was doing it and said, okay, let's try that at a server level. Like if all of our servers could reboot to get these file systems, it also made it safer to roll back. If something happened and this version 2 had a bug in it, all we had to do to switch back is we would tell it, hey, go reboot over here to this older file system and then reboot, and we can go right back to where we were. We don't have to worry about anything. There's a lot less risk involved in doing these updates because I always have the old version still available. Now, if I'm on version 2 and a new update comes in to the old version, it is a little bit more difficult because I have to forcefully tell it like, hey, go change that other partition to the old version before I reboot again. But in general, these updates don't come out every hour or every day or even every week. These are kind of a monthly, bi-monthly sort of thing. And so new updates can come out, they can be tested, and then I can push it down to this new partition and change back to that old partition. And this is still used today for a lot of operating systems. Like I said, Chrome OS and Android still do this. On the server side, things like Talos and BottleRocket do it this way. There's a lot of benefit here of just setting up 2 partitions and making sure those 2 partitions, one of them is always bootable. We always know one of them's in a good state and the other one's the one we're upgrading to. Now there is another way to do this, and this is called OStree. OStree is a bunch of files on your file system that is kind of like a Git repo, where my Etsy folder is on the partition, but it's actually a link to some other file on the system based on a hash. And this is how Git works. This is how a lot of other, like anything that's Merkle tree based, is it takes some identity from how those files, what files are there, and it basically hashes them in some way to figure out uniqueness for that file, and then it creates links based on that. In OStree, some of the benefits we get is we can have all of these things be links to other areas on the file system, and we can do this dynamically. We can set up our partitions, our A, B boot partitions dynamically. And so I can say, at first, my root file system is this AFE boot, and my partition B is going to be 9DA, right? Like it's some other identity which points to other links on the file system. And then we can have not only an A-B partition, but we can actually use multiple different partitions. We could have another identity, DAA, whatever. Like we can have all these identities around partitions, and we can choose which one to boot based on what we want next. And so we can do some experiments. We could always roll back because these files aren't changing. We're writing all of these files onto one disk, and then we're changing them dynamically with links on the hard drive. Now, using Git directly won't actually work for this for a couple reasons. One is Git doesn't track all of the metadata about files. It'll track basically files, their contents, and if they're executable or not, but it doesn't keep track of other things like who the owner is and all of the extra metadata about like SC Linux labels and ACLs around the file. All of that stuff isn't tracked in a typical Git repo because those are all unique to the person writing code. If you're using it to track your code, you're doing these things and you're modifying them, and I don't want someone else's user to own that file on my system. That should be me. In OStree, this is a distribution. This is a, hey, we snapshot this stuff of, here's an image, basically a SHA that you can take and run it on your system, and it can rewrite some of those things like a local user, but in most cases it can be like root. Right? Like root owns it, and that works great because we can still distribute these files like we would distribute a partition image, but we distribute a SHA, and if we need extra files, we can add these extra files as we do updates. And so I can just look at my entire tree and get a diff. I don't have to download the entire image. I can say, hey, here's what I have on disk. What else am I missing? And we can fetch the diff from this new SHA and then check out the new version for our B partition and then boot to it. This has some benefits over traditional partition booting, but it also has a little additional complexity because the system does need to be able to track all of these files. And if you have multiple partitions, you need to know which one's booting next. Most of those trade-offs are fine. In OStree, this might be a better solution depending on what you're doing. And OStree is how systems like uBlue and Fedora CoreOS use OStree. One really interesting thing you can do with OStree that you can't easily do with a partition system is layering, where this etcd again has some identity, and I can write that to disk and I can use that as what ID I'm looking for. But I can also say I want to layer on top of that some other files with some identity. And when the system is writing and making its OStree, it's going to take this layer and just merge it on top. This is how we work with container images. Container images are built of multiple layers, and it keeps just layering on top. And whatever the last layer to write is, that's the one that files take precedence. So if I want to install, say, a new application in bin, I can RPM OStree install some new file, and it will get layered on top of bin. And then if that file is brand new, great, it just writes it into place. If it's conflicting with an old file, it will override the old file that was there. I can take what's in bin and I can just put whatever I want on top of it. And all of those layers will get merged in, and the new identity up here for what I'm going to actually boot is the pointer to the top of all those layers. And so anything below it, they're still existing there. If there's an old, say, ls binary in this directory, it still exists. It's still on my disk. It's just not linked. It's not something that gets exposed to my file system as I'm using it because I'm using whatever the new ls is from my own layer. I'll just also point out real quick that OStree isn't using symlinks because symlinks don't keep permissions and all the metadata about files necessarily. It does use hard links for a majority of the contents. So even though there's a giant store of files on my disk, this is still using hard links to link all those files into a top level directory, which I can symlink in a writable space. But most of those top level directories, anything that goes back into that store directory where OStree stores its files, are going to be read-only, just like the partition swapping that we had before. And so I will have a separate area that I can write to, which can just be a traditional folder on the disk. I don't need to keep that in a separate partition. It's just somewhere outside of the OStree store instead of merging it in there and tracking it with all the other files. The last option I'll briefly talk about is Nix, and Nix is basically a package manager for file systems, but it's also just an idea around how you package this stuff. And Nix is a lot like OStree, but on a more granular level. Nix does do this environment linking and tracking for individual things, not just a file system. This isn't an A to B partition. This is like building the entire OS file system, choosing which versions you want of everything. So let's say I have an ls here in my binary folder, and it links to some glibc C3, which also needs some, LDD4, whatever. Like this link tree is created for every binary, and this isn't a global for the system. And so if I update my OS at this level, this environment can still exist, and I can still keep dependencies for every binary, every library on the system based on this tracking. And so it does a lot of the same stuff where it uses links for how it's going to write those files or how it's going to find those files based on the environment. And so it does act similarly to OStree at a much more granular level. This is also why Nix is good as a package manager and not necessarily needing it to run the entire OS, because you can install Nix on a Mac and it'll store everything in the /nix directory, and then you can use it. You can use executables from that, and you don't have to worry about how the system changes around that. There is a Nix OS which does this at the OS level. But in general, any packages you want, you can switch between them and keep older versions of a package around, because all of those dependencies are still on your file system too. And you're not relying on whatever lower level library is needed for that executable, because I can have, LDD4 and LDD5, whatever. I can have all those things can exist at the same time and be linked differently depending on how applications need them. So I just wanted to go over real quick how those things work, how they're different and how they're similar. This isn't super in depth, and I encourage you to go learn some more on your own. I think Nick's had one of the best comparisons out there on these different systems. So check out that link in the comments if you want to learn more. In general, A/B partition booting and OStree linking work similarly from an end user perspective, but how you're creating the images, how you're distributing them, and then how they actually get used on the system is a little bit different. With extra flexibility might come some extra complexity, but that might be a good trade-off for whatever it is you're using. So like a Chromebook is a great example of something that just works a lot of the time using A/B partitions. A server might do a little better if you need some more of that flexibility. All of them are great options to make sure that you run your systems in a scalable way, whether that's a laptop, a phone, or a server. But in general, you should try to pick one of these partition-based or rebooting-based file systems over a traditional install everything on disk, because long-term maintenance is going to be a lot easier when you segment off certain pieces to make sure you get those from upstream instead of overlapping something that you may have put on and changed and forgotten why you did it. If you have any questions, feel free to leave comments, and see you next time.